Hey everybody, welcome back for another session with Miss Hinkson. You are doing science and technology. We just finished looking at the birth of the solar system. So you guys looked at the planets a lot, and you know a lot about the planets. But then my next question for you is, well, what else is out there? Is it just planets? Well, some of you guys have really been talking about a lot of interesting things. So obviously, we know that there are other things out there, and we're going to look at them. All right. So again, when we first started this section, we started learning about the planets, and we knew that these were the terrestrial or the inner planets, also known as the rocky planets. And then they are separated by the asteroid belt. We never really discussed what that was, but we will look at that today. And then what were these outer planets called? Well, yes, they were called the gas giants. And the name was self explanatory. They are very large and they are mainly made up of gases. So that's where they got their name from. But what else is out there? There are other things that you guys talk about in your everyday language and you discuss these things, but you know what? There are so many different words. I realize that a lot of us do not know the difference between the other things that are out there in space. So, the first thing that we look at are natural satellites, or we call friends of the planets. So, a natural satellite is also called a moon. A natural satellite or a moon is a celestial body that revolves around a planet. Okay, so we're going to look at what that word celestial body is because that comes up a lot in your textbooks and all the other literature that we've been looking at. So, interesting is a moon or a natural satellite revolves around a planet. Now, where have you heard this idea of something revolving around something else? I'll give you about 3 seconds to think about that. Yes, so you guessed it. You can see that in this picture. Remember, we talked about the solar system. Why is it called solar system? Because the planets revolve around the sun. Now we have natural satellites, which revolve around a planet. So here we have Earth. The Earth is revolving around the sun. But at the same time, we see that we have a moon revolving around the Earth. So interesting, Mercury and Venus are the only planets without natural satellites. Something for you to remember. Jupiter has the biggest satellites, including Ganymede, which is bigger than Mercury. So imagine that this moon is actually bigger than the planet Mercury. So if you look in your textbook, you'll see that there's this table that summarizes a lot of information about the planets. But in this last column, it talks about the number of satellites that each planet has. And there's an asterisk here. So when you see a little star like that, that means that there's a footnote, there's something that you should be aware of. So if you follow that asterisk, we see down here the number of satellites known as of September 1st, 2005. Now that's something for you to think about. 2005, that was 14 years ago. So my question for you is, do you think the number of satellites is the same? That would be something for you to investigate when this slideshow is over. So you can go to the NASA website and check this out. Are these numbers all the same? Or have new moons been discovered? I'm going to leave that up to you to figure out and for you to tell me. But again, go to page 361 and you'll see this table. Again, that's in your Eureka textbook. All right, so what is a celestial body? This word comes up a lot, and I know I've said it in class, and I know some of you don't know what it is, which you just have not asked me, but we're going to talk about that anyways. So, a celestial body is a visible object. What does visible mean? Remember, we talked about light and the things that we can see? So, visible means we can see it. So, a celestial body is a visible object in the solar system, such as a planet, a comet. So, we're going to learn about those, and a natural satellite. We just discussed what that is. So, what is a star? We talk about that word all the time. Oh, I see stars. There's a shooting star. But do we understand what it means? Do we know the definition of a star? Are we able to tell a star apart from another celestial body? So, a star is a luminous ball of gas, mostly hydrogen and helium, held together by its own gravity. So there are a lot of words here that you've already seen in our previous lectures. So what does luminous mean? So that should ring a bell to you that luminous has to do with light. Okay, so it's a ball of gas, and a star gives off light. And hydrogen and helium, we saw that these gases are also present in some of the planets that we looked at. Can you remember which ones those were? And held together by its own gravity. So remember, gravity is that force of attraction, right? That holds things together, holds things in place. We discussed that gravity is what is responsible for keeping the planets in the solar system, and that's why they don't fall out of the solar system. So what is a comet? Anybody have any idea of what a comet is? Sometimes a lot of us know how to identify them in a picture, but do we know what they are? Because their images are quite distinct, they're quite unique, and it's because of what they are made of. So what is a comet? A celestial body, so there's that word again, made up of snow, ice, rock, and dust. It revolves around the sun in a long, narrow orbit and is followed by a bright tail. Okay, so again, we see this revolving around something. So what would make the comet stay on that path, right? How come it's revolving around and it doesn't go straight up, down? How come it's going around? All right. So we have many different images of comets. There's different parts, and different textbooks and different literature will show you different labeling, right? So the coma, inside of there's the nucleus, and there's the tail, right? This picture shows there's a dust tail and an ion tail, so there's a little bit more information. And if you go to page 362 in your textbook, there is also an image that talks about the tail, the head, and the nucleus, and it gives you the approximate size. Okay, so figure 74 in your textbook talks about a comet. It says a comet produces a new tail every time it passes near the sun. Since comets lose a little of their mass with each trip, they do not last forever. After approximately 1,000 journeys, or about 100,000 years, there is no ice left to evaporate. The comet is nothing more than a large rock. So think about that. The comet is going around the sun, and it says after 100,000 years, there is no ice left to evaporate. So what happens to the ice? Ice is normally cold. And what's the sun? Very hot. So what do you think is happening when the comet revolves around the sun? So we're going to go back to the textbook reading on page 362. When comets pass near the sun, they leave a great deal of debris behind. So remember, that's like broken up stuff. The Earth sometimes passes into a zone containing comet debris. When it comes in contact with the Earth's atmosphere, the debris burns and breaks up. At this point, from the Earth, we see shooting stars in the sky. When there are several, this is called a meteoroid shower. So we're going to talk about that. There are many words that revolve around that word meteoroid. You've heard of meteoroid, meteor, meteorite. We're going to discuss all of that shortly. So what is an asteroid? Asteroids are small rocky objects that orbit the sun. So here's that word again, orbit. So what motion should you affiliate when you see with the word orbit? Movement in a straight line or rotations, movement in a circular form, like a revolution, right? So you should think something circular or elliptical, but definitely circular and elliptical should come to your mind when you think about orbit, because we discussed orbits when we talked about the planets. Although asteroids orbit the sun like planets, they are much smaller than planets. So here's something, a link that you can go on to read a little bit more. So you can see this asteroid, it looks like a rock, right? It doesn't look like a planet. It looks irregularly shaped. It's got like holes in it. It doesn't look like a planet. It really looks like a rock. So these words, asteroids, meteoroids, meteors, meteorites, comets, etc., what's the difference exactly? Are we able to use these words interchangeably? Can I use any of these words when I want? Or do they have specific meanings for each one of these? Look at these ones. These look a lot alike. Are they the same? No. So we're going to talk about that. This meteoroid here, right? Look at where its location is, right? So an asteroid, when they smash into each other, they create meteoroids, right? And those are in space. Okay, and then what's happening over here? Hmm? All right. When meteoroids enter the Earth's atmosphere, so look, there's the Earth, this is the atmosphere, at high speeds and burn up, they become meteors. Okay? And then the meteors, if they're by themselves, are called shooting stars. And they're called shooting stars, right? We get that name because a star is this large body of gas that emits light, right? But this thing didn't actually produce light, right? That is like when it starts burning up. So it's not really a star. But if you have a cluster of meteors, right? So a bunch of them, that's called a meteor shower. Now let's say that this meteor manages to go past the atmosphere and land on Earth and land on the ground. Well, at this point, it is now called a meteorite. So we had asteroid, meteoroid, meteor, meteorite, okay, in that order. And again, you have to look at their locations. When they're in different areas, they are called different things. So this table summarizes what I just spoke about. First, you have an asteroid, which is a small rocky body that orbits the sun. Asteroids are left over from the formation of our solar system, which was 5 billion years ago. 2, what's a meteoroid? Well, when asteroids smash into each other, they create meteoroids. 3, meteor. When meteoroids enter the Earth's atmosphere at high speeds and they burn up, they become meteors. Next step. When a meteor makes it through the atmosphere and hits the ground, it is now called a meteorite. So this is a very interesting document that you can find on the Canadian government website. And I've linked the image here. So when you click on that, you actually have the image and you can zoom in and you can see what the different things are. So pay attention to, again, to their location and how they are called different things. So there's this word fireball, which is a meteor that burns as it travels through our atmosphere, leaving behind a very bright streak of light. Sometimes it is even visible during the day. This rather rare phenomenon is the result of a meteoroid that is larger or denser than usual. Okay, so this here is linked in the actual Google Slides show, so you can click on it when you have time. So let's just take a quick look at this couple of videos that kind of summarizes and gives a little bit more information about what I was talking about.
Welcome to Moo Math and Science. In this video, let's learn the difference between an asteroid, comet, meteoroid, meteor, and meteorite. An asteroid is a small rocky body that orbits the sun. Most asteroids are found between Mars and Jupiter. Some asteroids are metallic, while others are rich in carbon, which gives them a coal black color. Most of the asteroids in our solar system are found in a region called the main asteroid belt, which is found between the orbits of Mars and Jupiter. This video clip is a little deceiving because there is still a great deal of space between each asteroid. A comet is a celestial object made of frozen ice, gas, and dust that orbits the sun. When the comet heats up, it spews dust and gas, forming a glowing tail. And here's what a comet looks like. A meteoroid are fragments of space junk or rocks. They are created from collisions among asteroids, comets, moons, and planets. They are among the smallest space rocks that orbit the sun. When a meteoroid passes through the Earth's atmosphere, it heats up due to air resistance. The heat causes the gases around the meteoroid to glow brightly. This glowing meteoroid is called a meteor. In this clip, you can see some of the meteors flash by. A meteorite is if a rocky space fragment does not burn up in the atmosphere and strikes the Earth. It is called a meteorite. Here are some pictures of actual meteorites that struck the Earth. Now here's the sequence. You have a meteoroid in space, and when it enters the atmosphere, it is a meteor, and when it strikes the Earth, it is a meteorite. If you'd like to know more about other space objects, this playlist will help. And as always, thanks for watching, and welcome to Moo Math and Science. In this video, let's learn the difference.
All right, so this here is just another summary of what we just spoke about. And then we're just going to look at this other video that summarizes what we've been talking about as well. It gives a little bit more information than the other video we just looked at.
Space rocks. Our solar system is a vast and fascinating place. Between Mars and Jupiter, we find the asteroid belt. Due to the mighty gravitational effects of Jupiter, these chunks of rock and metal couldn't come together to form a planet, and instead made up a solar junkyard of sorts. This is a crowded place to be an asteroid. Sometimes they collide with each other and get knocked off course, and even out of the belt altogether on a very different journey through the solar system. There are lots of names associated with space rocks, so what's the difference? Well, the bigger rocks are called asteroids. The smaller are meteoroids. And when they fly through the Earth's atmosphere, they're called meteors. If they manage to survive their burning descent through our atmosphere and land on Earth, we call them meteorites. Some meteorites contain iron, which makes them very dense, dark, and magnetic. They are the oldest thing you could ever touch, as they are the same age as the solar system. The gas giant Jupiter marks a boundary in the solar system called the snowline, beyond which objects contain a lot of ice. Past the other three gas giants, we find a huge ring of ice chunks, large and small, called the Kuiper Belt, where the dwarf planet Pluto lives. Even more of these ancient, dirty snowballs exist in a huge bubble called the Oort cloud. These icy objects can get bumped off course sometimes to become comets that journey past the planets towards the sun. Some collide with other objects and get smashed to bits. Others head towards the sun and form long, beautiful tails as their icy surfaces warm up. Here they will either fall into the sun, never to be seen again, or they will survive and speed back home beyond the snow line. Here on Earth, we are treated to spectacular natural firework displays in the sky from orbiting comets. As they get close to the sun, they burp, splutter, and crumble, leaving behind a trail of debris. At certain times of the year, the Earth plows through these trails and bits of comet flare up as they fly through our sky and become meteors. The early Earth was hit by thousands of comets and asteroids. It is thought they brought water to our world. Comets may have also brought the ingredients of life to the Earth, and the European Rosetta mission could help us unlock secrets about the origins of life on our planet.
All right, so that is all we are going to look at in regards to what else is out there. So now I would encourage you to read pages 361 to 362 in your textbook. Next, we're going to be taking a little bit of a closer look to what happens to Earth in terms of its rotation and all that fun stuff. So, again, thank you for listening. And if you have any other questions, please email me at hingsons@loyola.ca. And also remember, guys, we have a lot more way to go in our journey. So, most likely, a lot of your questions will be answered by the time we finish the Earth and Space unit. So, just bear with me, have some patience as we make this journey together. Take care, everybody.